Okie dokie. In this problem, or in this video, I'll go through two examples of constant extrapolation and two examples of linear extrapolation. If you're looking for quadratic extrapolation, I'll do those in a separate video for this same number problem. So feel free to check those out if you're looking for those. In this one, starting with constant extrapolation, I'll just say the answer in the simplest way possible. When they mention using constant extrapolation, we ignore the f prime and f double prime values, and we jump straight to the f value. That negative 27 is our answer. All right, let's do one more. Use constant extrapolation. Right when we see that, we ignore almost everything else, and we look for the f value, and that is our answer every time. I won't go into the conceptual stuff until we get to linear here. So once we put together the whole linear idea, you can maybe make sense of it for the constant. So linear extrapolation. The idea with extrapolation in general is to be given certain information, like very minimal information about a function and maybe its derivative or multiple derivatives, to construct the function. So our goal will be to construct a function f of x. And with linear extrapolation, the idea is we want to construct a linear function. Generally, linear being the equation of a line, mx plus b, but in this case, we'll use a's and b's. So we'll call it ax plus b. So we are trying to identify what a is and what b is. And if we have those, then we have our linear function, f of x. And so in this case, with linear extrapolation, we'll have f, and from this, we want to find f prime. And so in this general sense, using a's and b's, what is the derivative of ax plus b? A times x is a constant times x. So the derivative is just that constant. Think about if we had like 7x. The derivative would just be 7, right? And then with the derivative of plus b, that is just a constant. So a constant's derivative goes to 0. So f prime is just equal to a. So now what do we do with these? Starting with f prime, we're going to set this f prime equal to this f prime. So what that's saying is f prime at negative 3 is equal to 3. But we know that f prime, no matter what, is equal to a. So what we do is set 3 equal to a, because we know this is equal to f prime. So we could plug in, negative 3 to this, and really there's no x value to plug in negative 3, so it just remains a. So just like that, we find that our a value is 3. Pretty cool. Now, so I plugged 3 in the place of a in the function f. So now we work backwards to f. And we use this information along with this representation of f of x that we have in order to solve for b. So we're going to set negative 4, the f value, equal to 3x plus b. But we also know that f is only negative 4 when the x value is negative 3. So we replace the x with negative 3. And doing this makes it so that b is the only unknown in this equation, so it allows us to solve for b. So we get negative 9 plus b equals negative 4. We add 9 on both sides, and we find that b is equal to 5. So just like that, we found a and b. b equals 5. So now we have our linear function, 3x plus 5. And I've covered it up a bit, but the goal then is to extrapolate the function's value at negative 1.7. All that means is once we've identified the function, we're going to plug in the x value, negative 1.7, and find the f value, or the y value, right? So let's open up Desmos. We are plugging in 3 times x, or 3 times negative 1.7. plus b, which is 5. So plus 5 gives us negative 0.1. Negative 0.1 is the y value that we're looking for. So we break out the eraser to see that d is our answer. So we are constructing the function f using linear extrapolation. Therefore, we are finding a linear function of the form ax plus b. We find its derivative. In every linear extrapolation case, f prime will just be a. So then right away, we set this f prime to this f prime. So a will equal negative 2, just like that. And then we work backwards to our f function. So we know that f of 0 is negative 4. So we basically plug negative 4 in place of this f, and then 0 in place of this x. So negative 4 equals negative 2 times 0, or negative 2 times x, plus b. 0 times negative 2 turns to 0. So it turns out that we just have negative 4 as b. So plus negative 4, I will just call negative 2x minus 4. Now, we're extrapolating this function's value at 0.5. So we plug in 0.5 to this function. So negative 2 times 0.5 minus 4. So negative 2 times a half is negative 1. Minus 4 is negative 5. So some of these we might be able to work out by hand like this. Other ones, it might be helpful to use a calculator. I hope this all makes sense. If you have any questions, please let me know. Otherwise, feel free to check out the quadratic extrapolation video I'll do next. Alrighty.